vLabs विषय पर आधारित है और यह कार्यशाला महाविद्यालय के विज्ञान संकाय एवं बीवॉक संकाय के साथ साथ अमृता विश्व विद्यापीठम यूनिवर्सिटी के संयुक्त तत्वावधान में आयोजित की जा रही है। आज कार्यक्रम में अध्यक्षता कर रही हैं हमारे महाविद्यालय की प्राचार्य मैम प्रोफेसर डॉक्टर दिव्यानाथ एवं विशेष अतिथि के रूप में हमारे मध्य उपस्थित हैं मिस्टर आर वेंकटेश, मैनेजर लाइसेंस टीसी अमृता विश्व विद्यापीठम, मिस्टर सानिस पीएफ, प्रोजेक्ट मैनेजर टेक्निकल लीड ऑफ फिजिकल साइंसेज वर्चुअल लैब्स अमृता विश्व विद्यापीठम एवं मिस्टर जॉयदीप नाग, हेड टेक्नोलॉजी इनेबलिंग सेंटर अमृता विश्व विद्यापीठम। जैसा कि हम सभी जानते हैं कि पिछले 2 वर्षों से भी अधिक समय से हमारा विश्व, हमारा पूरा देश, हम सभी कोविड-19 नामक महामारी से बहुत बुरी तरह प्रभावित हुए हैं। इस महामारी ने हमारे समक्ष अनेक चुनौतियां रखी, अनेक समस्याएं रखी और हम सभी मानव जाति ने मिलकर प्रयास किया इसका सामना करने का, इससे लड़ने का। उन्हीं चुनौतियों में एक चुनौती हमारे समक्ष आई शिक्षा व्यवस्था की, कि कैसे इस कठिन दौर में शिक्षा प्रणाली को बिना बाधित हुए, बिना उसके अंदर कोई रोक टोक आए संचालित कर सकें, आगे बढ़ा सकें। और इस कार्यक्रम में, इस हमारे इस संयुक्त तत्वावधान में, संयुक्त प्रयास में हमारे साथ सबसे ज्यादा जो हमारा सहयोग रहा वो ऑनलाइन प्लेटफॉर्म का रहा। जो भी ऑनलाइन प्लेटफॉर्म्स थे जैसे कि जूम है, वेबएक्स है, गूगल मीट है, माइक्रोसॉफ्ट है, इनकी मदद से हमने पूरा प्रयास किया कि हम इस कठिन दौर में भी अपनी छात्राओं को, अपने छात्र को इस महामारी से बिना प्रभावित हुए शिक्षित कर सकें, उनका ज्ञान वर्धन कर सकें। परंतु समस्या आई हमारे समक्ष जब प्रैक्टिकल विषयों के संबंध में हमने प्रयास किए, तो प्रैक्टिकल विषय, उनमें प्रैक्टिकल्स डालने का, प्रयोगशाला का पर्पस ही यही था कि वो विषय बिना प्रयोगशाला में गए हुए पूरी तरह समझ पाना संभव नहीं था। उन विषयों को समझने के लिए हम जब प्रयोगशाला में जाते हैं तो उसके थ्योरेटिकल नॉलेज के साथ साथ हम उसका वो ज्ञान प्राप्त करते हैं जो जीवन भर हमारे साथ रहता है और जो वास्तव में हमारे लिए उपयोगी सिद्ध होता है। उस जगह पर कहीं ना कहीं हमने महसूस किया कि हम अपंग थे, हम पूरी तरह उस समस्या को सॉल्व नहीं कर पा रहे थे। इस समस्या का समाधान निकालते हुए वर्चुअल लैब्स हमारे समक्ष आई और इसके विषय में और जानकारी देने के लिए आज की यह कार्यशाला आयोजित की जा रही है, जिसमें हमारे जो एक्सपर्ट्स हैं वो हमारा ज्ञानवर्धन करेंगे। मैं पुनः एक बार हमारी प्राचार्य मैम का, उपस्थित समस्त गणमान्य जनों का, समस्त प्रतिभागियों का हार्दिक स्वागत करती हूँ, अभिनंदन करती हूँ और माँ सरस्वती का आशीर्वाद लेते हुए प्राचार्य मैम से अनुरोध करूंगी कि वो हमारे अतिथि महोदय का स्वागत करें एवं अपना उद्बोधन दें। स्वागत है मैम, डॉक्टर दिव्यानाथ मैम।
Thank you, Neha. At this virtual lab presentation workshop that we are organizing today, I would first like to welcome our guest speaker, Mr. Sanish P.F., and all other dignitaries who have joined us on this online platform from Amrita Vishwa Vidyapitham, and the staff of my college who is organizing this workshop. Welcome to all from this college platform. As you all know, technology has changed the face of education in recent times. जैसा भी हमारे केमिस्ट्री की टीचर डॉक्टर नेहा ने बताया कि कोविड-19 के इस दौरान जो लोग टेक्नोलॉजी से इतने ज़्यादा फेमिलियर भी नहीं थे, they started using technology through online classes etc. इसी चीज को आगे बढ़ाने में एक नेक्स्ट स्टेप होता है जो कि साइंस की पढ़ाई में बहुत ज्यादा जरूरी है. इट इज एन इंटीग्रल पार्ट ऑफ द स्टडीज इन साइंस एंड दैट इज द प्रैक्टिकल वर्क दैट इज allotted in all the subjects, which is an integral part of the syllabus. अगर वो प्रैक्टिकल, क्योंकि जैसे थ्योरी क्लासेस हम लोगों ने देखा कि लास्ट 2 years से मोस्ट ऑफ द टाइम वी बीन होल्डिंग ऑनलाइन क्लासेस फॉर आवर स्टूडेंट्स, तो वो थ्योरेटिकल चीजें तो वहां पर हो जाती हैं, लेकिन प्रैक्टिकल के लिए अभी तक यही सिस्टम था कि उनको कॉलेज में आ करके और प्रैक्टिकल्स करने पड़ते थे. तो इसमें एक जो ये वर्चुअल लैब का जो सिस्टम आया कि विदाउट विजिटिंग द कॉलेज, विदाउट विजिटिंग एनी लेबोरेटरी, यू आर एबल टू do all kinds of dissections and practicals while sitting at home. this has really changed the face of education. And it is a matter of great pride that our college has become one of the centers of this virtual lab, which has been started by the Ministry of Human Resource Department under National Mission on Education. So through the use of ICT, our science faculty and the vocational courses that we have in 2 subjects, they will have now the opportunity of conducting practicals through these virtual labs. This is especially a boon for colleges which are situated in remote areas. जैसे हमारा college है, it is situated in a rural area of Delhi NCR, and we can say कि since it's a government college, तो हमारे पास funds की भी कमी होती है, तो most of the time we are not able to purchase a lot of equipments that are required for state-of-the-art laboratories. So this kind of virtual lab system is a boon for remote areas as well as for economically challenged colleges which are situated in different remote areas. तो अगर बच्चे अपने घर बैठे हुए जो फैसिलिटीज उनके कॉलेज में अवेलेबल भी नहीं है, जो इक्विपमेंट्स अवेलेबल भी नहीं है, अगर उसको वर्चुअल मीन्स से यूज करके और उस पर बहुत कुछ सीख सकते हैं, so then I think it has really changed the face of education, as I said before. इसके साथ साथ ये इको फ्रेंडली भी है. आप बहुत से डिसेक्शंस के लिए आपको एनिमल्स चाहिए होते हैं और डिफरेंट केमिकल्स चाहिए होते हैं. अगर उनको हम बिना यूज किए हुए उनका यूज वर्चुअल लैब से कर सकें तो इससे अच्छी क्या बात हो सकती है. So this first workshop that we are organizing today for the benefit of our students, and several participants who are also joined with us on the YouTube link. तो मुझे लगता है कि सब लोग अपनी जगह बैठकर इस चीज को इस ऑनलाइन प्लेटफॉर्म के थ्रू देखेंगे, समझेंगे और सीख पाएंगे. और सिर्फ साइंस में नहीं बल्कि हमारे यहाँ जैसे आर्ट्स के भी स्टूडेंट्स हैं जो कि ज्योग्राफी पढ़ते हैं या होम साइंस पढ़ते हैं, उनके सिलेबस में भी अगर कोई पोर्शन ऐसा है जो वर्चुअल लैब के थ्रू सीखा जा सके तो ये आर्ट्स के सब्जेक्ट्स को भी जो है उनके लिए भी बेनिफिशियल होगा. So again, I welcome all the people who have joined us from Amrita Vishwa Vidyapeetham, and our guest speaker for today, Mr. Sanish PF, who is the project manager and technical head of physical sciences of virtual lab at Amrita Vishwa Vidyapeetham. Welcome once again, and I hope and I'm sure, I'm not only hopeful but I'm very sure that this workshop today is going to be very beneficial for not only our students but also for our teachers who joined us. So thank you once again. Thank you.
Thank you so much, ma'am. हृदय से आभार आपका, आपके काइंड एड्रेस के लिए, आपकी ब्लेसिंग्स के लिए. और इसके बाद हम अपने इस कार्यशाला को प्रारंभ करते हुए मैं आमंत्रित कर रही हूँ मिस्टर सनीश पीएफ सर को कि वो टेक्नोलॉजी एनेबलिंग सेंटर के विषय में हमें बताते हुए आज के इस विषय पर हम प्रकाश डालने का प्रयास करें. स्वागत है सर, मिस्टर सनीश पीएफ.
So thank you, Nisha. So sorry for the mistake. So actually, Venkatesh will be presenting about the Technology Enabling Center. So I'll just give you a brief introduction about that. So Technology Enabling Center is another project funded by DST. So that will be something useful for the faculty members or students, those who have any innovative idea for future developments of any technology. So I will introduce Venkatesh for a small presentation regarding the TEC. After that, we will continue about virtual lab session. Thank you.
Okay, sir. I would like to invite Mr. Venkatesh, sir, for giving us introduction about Technology Enabling Center. You are welcome, sir. Please continue.
Thank you, ma'am. Thank you for the introduction, and good afternoon to all the faculty members, and also greetings to the students. So I represent, my name is Venkatesh, and as Sanish was mentioning, I'm holding the position of license manager in the Technology Enabling Center. Hope you can hear me. Is it audible?
Yes, sir.
Yes, sir, you are audible.
Okay, thanks. So a Technology Enabling Center is, let me present my screen over here. Are you able to see the screen?
Yes, sir.
Okay, sure. Thanks. So when I say the technology enabling center, what exactly is it? There are so many technologies and virtual labs and all these things are available. But what exactly the technology enabling center is it that is Government of India and the Department of Science and Technologies had identified about 9 institutes across India, and Amrita is one of them. And to enable the technology, identify the technology available with the people, and to take it to the commercialization level to where it can be helpful for the society. So this is the main motive of the entire technologies. There are so many people. I don't know you, as you see the vision and vision of the enabling technology over here. We would like to build an ecosystem of through academia partnership through academia, industries, and go-to-market partners. That is industries or MSME units or trade bodies. All these things put together, bring out the technology what you have to the commercialization purpose, so that it will be helpful for the society, beneficial for the society and beneficial for us also. So this is the main motive beyond the technology enabling center. So what exactly we do in technology enabling center is we assess the technologies. The first of there are if you say that there are TRL, technology readiness level for any product to come out to the market. So the technology assessment of technology readiness is the first aspect of the this step what we are going to do, and we will see that where the technology stands. So if it is in the first stage, the stage 1, stage 2, or stage 9, when it has reached the stage 8 and 9, it is a product is almost ready and go to market. So in this level, we identify that if you have a technology, how to take it to the next level. Whether you and if it is in the between the 5 and 6 and 7, it is a prototyping and a testing stage of the technology. So at that time, if there is no capability or the infrastructure is not available with particular academia or as a industry, we will connect with you to the industry where we have expertise, so that they can be built. The prototype can be built, also testing can be done with a minimal cost to the system. And if there is any individuals who has the researchers, it is the beneficial to both the researchers inside Amrita and as well as the outside. So if there is any researchers outside, but they do not know the know how to take it further, so we will be enabling them through this technology enabling center. This is what the main motive of the technology enabling center. So as I told you, because these are our partnerships, we have the who are there with us, knowledge laboratories, and for the value added products like IP, internet, intellectual property rights, trade bodies, and also MSME DI threshold, and we have the MSME DI across all the units. Like in Kerala, we have a tie-up with threshold, and also minimize. Likewise, we are also having the tie-up with the MSME development institutes in other parts of the state also, and also we are also talking to the people in Karnataka, Tamil Nadu, and other places. So, and secondly, the academia. So you may be having a know-how in the academia. You may be doing some research, so which is beneficial, and you would like to take it further up. So if you are having such a kind of technology, we would like to help you to take it further. And if you have any in-house expertise in our institute, we will help you to take it further. Or if you want to do the partnership, or you want to do the prototyping or testing, we will help you to identify MSME or an industry where they'll be ready to invest in your product or fund your product to take it to the product commercialization level. And commercial, as I told you, these are our commercialization focus, where we do commercialize. We are doing from the Amrita Technologies, co-creating the technologies along with the researchers. And there are certain projects which has been identified by the Department of Science and Technology, which is funded by the Government of India. So that also we are identified, and we are taking it further to the commercialization. So, and meanwhile, while creating the ecosystem, we are also talking to the, we have a tie-up with the IIT Madras, GDC IIT Madras, where we are testing and prototyping is currently being done. And time to time, we also conduct the smart city hackathons and other things, and webinars and workshops on various topics like IPR related issues, and what are the various schemes available under MSME DSP. As you see in the screen, I'm just running through the screen, but there's a lot of things which are to be there. There are creating an ecosystem, co-creating the technologies, manufacturing, and distribution. Distribution, finally, we'll be identifying the ecosystem for the development of co-creating the technology, as well as the marketing the product where it needs to be marketed. So marketplace, our where we can market your product, that also we'll be able to assess the situation. So organization structure, what are the things what we are going to do? We are connecting the industry connects, we are connecting the researchers. As we mentioned earlier, it is also connected with the IP, commercialization connect, and communication. So communicating to the in relevant places, how we are going to do it, what are the various ways we can collaborate, and also the required training and the skill sets, what is required to go further, and what are the various aspects like legal and patent issues which are coming into the for the researchers to take it further to the commercialization process. So this is what we are into the technology enabling center is currently into the, and these are some of the technologies which has been developed during the corona period, the pandemic period what we had in Amrita. So this is the ultraviolet sanitizer which is developed by one of the researchers inside Amrita, and this is a PAPR kit what you can see over here, useful for the frontline medical workers because they will be fatigued whole day they'll be under this suit. So it is a purifier, powered air purifier respirator, which will be keep their cool and then they work for longer hours. And similarly, we also came up with a self-driving wheelchair, which is which can be controlled with Android telephones, and also the nano mask for the during the corona period. And these are some of the technologies which were developed and transferred to some of the industries, startups which has happened from Amrita. So they have, the plastic proof and RCP payment tiles and RCP proof tiles, all these things which we have transfer the technology also developed inside Amrita, but technology is transferred for the product manufacturing. And this is another product which is made from the banana fiber, Saukhyam for the ladies, and which is already in the market, available on the e-commerce platforms. And what we can do, we would like to, as I mentioned earlier, we would like to do the skills and training, fulfilling the MSME needs also, and competition and internships along with the institutes and as a nodal center, right? We have tied up with several nodal centers across India. As a nodal center, what you can do to achieve this? So achieve the to take the technology from the initial level to the commercialization level. How we can help us? If you have a technology, if you know somebody who has a technology, who has an idea, you can reach it out to us so that we can talk to the person and to take it to the next level. And through the process, we can also take it to the commercialization process also, commercialization level also. So this is what actually in a brief, I have mentioned what Technology Enabling Center is doing, and which will be helpful which will enable the aspiring students who would like to get into the research to benefit to the society, and also faculty members from your institute who are into the research and then developing the various products or various ideas you have. If you want to take it further up, you can reach out to us, and we will be gladly able to help you out. So this is what I wanted to mention here. And if you have any question on this, you can ask me so that I'll try to help you out in clearing the doubts. So this is about the Technology Enabling Center, what I just wanted to brief you about.
Any question? बच्चों कुछ पूछना है किसी को? सर ने पूछा आपसे, तो कुछ अगर आप जानना चाहते हैं सर से? Okay, thank you so much, sir, for an extensive introduction of the Technology Enabling Center. And I'm very sure that we all are going to learn a lot from this enlightening workshop. Thank you so much once again.
Thank you so much. And I think Sunny sir will be sharing the email ID for the Technology Enabling Center. In case you require any further details about the same thing, you can reach out to us.
Okay, thank you so
Sunny.
much, sir. Thank
Thank
you.
you. Thank you.
So then
Thank
the
you, everyone.
sequence-
Sanish.
Yeah, thank you, Venkatesh.
Further, I would like to invite Mr. Sanish PM sir for giving us introduction about virtual labs and about for the technical session. So, स्वागत करती हूँ. I welcome you, sir.
So thank you, Nehama. So respected principal and HODs and nodal coordinators and dear students from KM Mayavati Government College. So warm good afternoon, all of you, and welcome to the online virtual lab training session. So as you all aware, we have a lot of challenges we face during this COVID time, right? But due to this COVID time, we have learned a lot. We learn to use this online platform like Zoom, Google Meet, etc. And also the faculty members, they are using different platforms for teaching their students. So I also salute to all the faculty members without taking any break on this, even in the COVID situation. We have wonderfully carrying out this teaching session without any break. But this practical session, that is one of the major challenge faced by all the institutes all over the world. So this virtual lab come up with some part of supporting for institute for handling these practical laboratory sessions. So today I'm going to introduce what is virtual lab project diagram and how to effectively use this platform. And after this, definitely each one of you have to practice yourself. Then only that will be benefit for your career. Okay. So with that, I will just start presenting my screen. So in between, if you have any questions, please note it your notebook. At the end of the session, you can feel free to ask me or type it on the chat box. So I will try to answer all the queries. So with that, I'm just start my presentation. So are you able to see the screen? Sir?
Yes, sir.
Okay. All right. So once again, welcome to Virtual Lab online session. We call it as Value Virtual Lab, which stands for Virtual Amrita Laboratories Universalizing Education. It is being funded by Government of India under Ministry of Education, National Mission on Education on Information and Communication Technology. Okay. So a little bit about our university. The Chancellor is Mada Amrita Devi, the spiritual leader. And Amrita is recognized as #1 private university in India as per the THE World University ranking, and also the 4th top private university as per the QS World University ranking. And also we are recognized as 4th best ranked university as per National Institutional Ranking Framework. So also we got the Institute of Eminence recognition by University Grand Commission. So these are some of the achievements of Amrita University. So before starting the session, I would like to go through some thought process. So is there something wrong with our education, or is the present system of education is sufficient? So this is the basic thought behind the development of our virtual lab project. Okay. So because in our classroom scenario, one faculty members may not be able to handle all the different category of students. So only the capable students, those who are interested, they can easily understand the concept. But other students are simply drawback, or they cannot perform much in the academic career. So that will also affect their future. Okay. So if you are looking these pictures, as you can see, left-hand side, you can see the telephone, which is around 100 years old. And right-hand side, you can see the modern smartphone, which is, you can see all the features, options, etc. Okay. Similarly, if you are comparing with our automobile, the left top, you can see the automobile, which is almost 100 years old. And right bottom, you can see the modern automobile that has all the safety features, automation, etc. All right. So if you are comparing with our traditional classroom, so the left-hand side, you can see the classroom, which is almost 100 years old. And right-hand side, you can see the modern classroom. So only thing is different. Instead of blackboard, we are using gray board or whiteboard. And sometimes we are using projector, screen, etc. But the method of teaching is almost similar in both situations. So that is not a drawback of the faculty, but it is a challenge faced by the faculty for taking care of each individual student from their classroom. Okay. So as you know, traditional laboratories, we are providing much importance for the laboratory courses because we are considering it as the beginning stage of the students, those who are going to explore and solve the real world problem in the future, right? So if you are providing a laboratory experimentation, students have to identify what are the objectives, and they need to identify the step-by-step procedures, and they have to implement it to solve the objective of the experimentation. So that is the beginning step of solving the real world problem. So they need to apply this methodology in the real life as well. So that's why we are providing such importance to the laboratory session. But unfortunately, several institutes are not able to afford this costly equipment. So that will also affect on students' learning skills, and that will also affect on their academic score, right? So these are some of the institutes we have visited as part of the Nodal Center program. So as you can see, there are poor laboratory situation. So that will also impact on students' learning. Okay. So these are already existing technologies world around. So the left top, you can see the pilot simulator. So all the pilot train using this type of simulation before handling the actual aircraft. So advantage of using this, their fear of handling the real aircraft will be dramatically reduced, and they can the pilot will get the training of most rough and tough situation that can happen in the real life. So once they have got this type of training, they can easily handle the real aircraft. So that is the advantage of using this simulation. And the right top, you can see the remote trigger system, which is called Da Vinci. So our actual doctor is placing somewhere other geographical location. So he or she can perform the real-time operation using this type of technology. So this is called remote trigger technology. Similarly, the left bottom, you can see the driving simulator. First modern world, we are using this type of simulator for providing the driving license and training as well. Okay. Similarly, the right bottom, you can see the augmented reality. Mostly medical students are using this type of technology. So they are using the VR headset. So through that, they can just and see what are the subject three-dimensional view and what are the things they have to learn inside the subject. So they can dissect the view and they will get a better idea rather than reading from the textbook. Okay. So these are already existing technology, but why we are not implementing anything into our laboratory session? That is the major motivation for developing this virtual lab project. Okay. So with the help of Government of India, Ministry of Education, and under the project National Mission on Education through Information and Communication Technology. So we 12 institute come up with this virtual lab project and we implemented it successfully. So these are the 12 institutes that participated for developing this virtual lab. So Amrita Vishwavidyapeetham is one of the partner institute. Similarly, you can see IIT Bombay, IIT Kanpur, IIT Delhi, IIT Kharagpur, IIT Madras, IIT Roorkee, IIT Guwahati, IIIT Hyderabad, the Dalbagh Education Institute, National Institute of Technology, Karnataka, College of Engineering, Pune. So these 12 institutes are developed all virtual lab projects, whereas Amrita is mainly focusing on science background, physics, chemistry, biotechnology, etc. And IITs and other engineering colleges are focusing on engineering branches like mechanical engineering, civil engineering, EEE, etc., computer science, etc. Okay. So I just want to introduce our principal investigator of Amrita Virtual Lab. This is Dr. Krishnashree Achyutan. She is the Dean of PG Program and School of Engineering, and she is the Director of Cybersecurity Systems and Network in Amritaburi campus. And she is the principal investigator of Virtual Lab project of Amrita Virtual Lab. Okay. So myself, Sanish, I am project manager of Virtual Lab project. So the motivation behind this Virtual Lab is the physical distance limiting doing the experimentation. So in our traditional classroom scenario, students can access this virtual lab only at the allotted time. So what will happen if the students or they are not able to complete the experiment, or if they want to perform the experiments at the late night or early morning? Usually that is not possible. But that is one of the barrier for completing the experimentation for the students. Okay. So another one is the cost-effective and hands-on experience. Because of some equipments are really costly, students are not allowed to directly play with those equipments. So for example, in engineering science, and there is several equipments called universal testing machines and etc. So usually the lab instructor performing the experimentation. So students can observe how he or she is performing it, and they can take the reading from the equipment, and from using the reading, they can find out the objective of the experimentation. But mostly they are not, students are not allowed to directly change parameters of the equipment. So because that will, if the equipment is damaged, it will cost more than lakhs for maintaining it. Okay. So that is another barrier for performing the experimentation. And another one is the sharing of costly equipment. So student, usually it is not possible one institute students can visit any other nearby institute or IITs. So for completing the experimentation. So that is one of the drawback for our education, our school scenario. But through this virtual lab platform, we are virtual lab nodal center program. We are providing an opportunity for the students from the nodal centers to visit either Amrita University or any other prominent institute to visit the laboratory facilities, and they can explore more about the laboratory equipments related things. Okay. So combining into 4 points, it is to provide a remote access to lab in various disciplines of science and engineering. And second one is to cater the student at the UG level, PG level, as well as to research scholar. And third is to enable the students to learn at their own pace and arouse their curiosity. And fourth is to provide a complete learning management system that includes web resources, video lectures, animated demonstration, and self-evaluation. So the one of the advantages of using this platform, students can learn at their own pace. So they don't need to search for any other resources for Google or any other search engine. So all the required contents are available in one platform. And also they can utilize this platform at their convenient time, maybe the late night or early morning. Whenever they are convenient, they can use this platform for completing the experimentation. So these are the broad areas of lab we have. We have biotechnology and biomedical engineering, chemical science, physical science, electronics and communication engineering, computer science and engineering, electrical engineering, mechanical engineering, civil engineering, chemical engineering, etc. So basically, there are 4 types of labs available under this virtual lab platform. One is called animation type. So animation is just like a watching video. So when the students watch this type of animation, they can easily memorize what are the steps they have to perform in the real laboratory. So in this animation, there are subtitles are provided, and the students can hover the mouse over each of the equipments. So the name of the apparatus will pop up. So they will get a better understanding about the shape of the apparatus, name of the apparatus before coming to the real laboratory. So that is the advantage of animation. And another one is the interactive animation. So interactive animation is just like a animation, but some part of the animation students can interact with it using the keyboard and mouse. Okay, so they have to interact with it, then only it will continue. So the advantage of interactive animation, that particular step the students will easily memorize. That are the very important steps they have to carry out in the traditional laboratory. So for example, some experiments they have to use the mouse pointer for taking the solutions and mixing it up. So they can, when they are performing multiple times, they can easily memorize the procedure when they are performing in the traditional laboratory. So that is the advantage of using interactive animation. And third one is the simulation type experimentation. So the simulation is just a replica of our traditional laboratory setup. So students can see all the equipments and apparatus in a schematic diagram. And there is a control panel in the simulation window. So they can change parameters of the equipments. And in real time, they will get the data from the simulation window. So that is called simulation. And fourth one is the remote trigger experiment. So that are the cutting edge technology developed by Amrita and other IITs, where actual apparatus are kept in either Amrita or IITs. So students get an opportunity to perform the real apparatus related experimentation. So they can log into the portal and they can change the parameters of the real apparatus. So from the real apparatus, they will get the real time data. Using the data, they can find the objective of the experimentation. So that is called remote trigger lab. But as of the since COVID situation, we have shut down most of the remote trigger lab. So currently, we are not able to access this lab, but we hope we will bring it back after a couple of months. So these are the schematic diagram of animations or interactive animation. So right hand side, you can see all the animation window look like. So there you can see the apparatus and equipment that usually students have to use in the traditional laboratory. So this is the schematic representation of simulation. So the right hand side, you can see the EMF measurement experiment. So you can see there is a 2 beaker connected with the electrode and cathode and anode, and they are connected with the U2. Okay. So there is an ammeter, a voltmeter over here. And the right hand side, there is a control panel where students can vary the parameters of the experimentation. for this particular experiment, you can see the temperature and the cathode electrode, anode electrode, and concentration of the solution. So many parameters they can change, and it will provide a real-time result into this voltmeter reading. Okay. So this is called simulation, and this is the remote trigger lab. So the right hand side, you can see the representation GUI of the remote trigger lab. So you can, where students can see the live streaming of the apparatus, and also the platform will provide the result as a graphical representation, and they can export the result as CSV file, and they can analyze it using the data analysis tool. So these are the architecture of the remote trigger lab. Left hand side, the users log into the portal, and they can access our remote trigger server using internet. So this RT server connected with our remote trigger peripherals, right, like IP camera, digital acquisition system, and all other peripherals. So a little bit about the development step of the virtual lab. So there are, you can see there are several steps for developing this virtual lab. So initially we have conducted a survey all over India with almost all the universities in India, and we have come up with a list of experiment for development or converting into a virtual lab. So one of thing I would like to mention, still we are not included all the labs, all the experiments in this platform, because we are next phase of adding new experimentation, because we are currently we have selected most popular experiments that are used by most of the universities in India. Okay, so that faculty members, you can, if you find any important experiments are missing, we can create a list of experiments for the future development of virtual lab. Okay. So after identifying the experiment, we have created a storyboard with the help of subject matter expert. After that, with the help of software engineers, we created these animations and simulation. And after that, there is a review committee. We'll review each of the content and animation, simulation, etc. So once it is approved, we'll comment into the virtual lab server. So once it is commented into the server, all the users can access all the resources free of cost. So these are the labs under biotechnology and biomedical engineering. So as you can see, we have biosignal processing and analysis, bioinformatics, neurophysiology, biochemistry, population ecology, immunology, microbiology, etc. So there are a lot of labs are available under this biotechnology and biomedical engineering. So each of these lab, you can see at least 8 to 10 experiments from each of the lab. So similarly, this is the chemical science lab. So we have physical chemistry, organic chemistry, inorganic chemistry, and analytical chemistry lab. So these are the labs under physical science. So we have electricity and magnetism virtual lab, heat and thermodynamics, harmonic motion and waves, modern physics, laser optics, mechanics and advanced mechanics, electric circuit, optics virtual lab, and solid state physics. Okay. So you can find at least 5 to 10 experiments that is mapped with our curriculum. So we have included most popular experiments in this platform. So I'm still repeating, if you find anything missing in this platform, you can still send us the list of experiments for the future development. So we have some mechanical engineering labs also available, wind energy, solar energy, mechanics of solid. So most of them are remote trigger lab. So currently you can access all the content like theory procedure, but the labs are under maintenance. So you may not be able to this remote trigger lab right now. Similarly, there are one wireless labs are available, wireless sensors and network. So one of the advantages of this interdisciplinary, those students, those who are interested, they can go and explore other laboratory section also. Suppose the students from physics, they can also go and explore some lab from chemistry or other engineering branches if they want to. So that is one of the advantages of using this platform. So this is the Amrita Virtual Lab website, vlab.amrita.edu. So I request all of you to note down this site address, vlab.amrita.edu. So this is where we are going to explore more experimentation. Okay.
Thank you, sir.
Yeah. So once you have gone to any of the experiments, you can see there are several tabs are arranged. Start from theory, procedure, self-evaluation, simulation, assignments, etc. So why we are keeping it as a separate tab? Because students have to follow each tab carefully for getting the complete idea about the experimentation. Okay. So they can start with theory. So once they are referring to theory, they can go to the procedure, self-evaluation, etc. So this is much more easier for the students to skip over any of the tab. So once they have completed theory, they can directly go to the simulator or any other assignment, etc. So that's why we are keeping it as a separate tab. So most of the experiment, we have included the video tutorials also. So that will provide a better insight about the experimentation. So this is the main website, vLAb.co.in. So you can also note down the site address, vLAb.co.in. So from this website, you can access all the virtual labs developed by all prominent institutes. So other IIT virtual labs also you can access from this platform. Okay. So this is the launch of this virtual lab project on 23rd February 2012 by the ministry, MHRD ministry, Kapil Sibal. So after launching this project, we provided these resources as free of cost to all the educators and institute all over India. So these are some of the prominent visitors of virtual lab. So the left hand side, you can see the Nobel laureate Carl Wilmette, and right hand side, the blue shirt guy, that is Nobel laureate Dr. Leland Hartwell. So what they are commenting on this virtual lab, this is dramatically reduced the time for real experimentation. So which is true, when the students go and explore using this type of platform, they can effectively utilize the time for completing the real lab experimentation. So a little bit about the Noda Center program. We are implementing this virtual lab through this Noda Center program. So your institute is one of the Noda Center under this virtual lab project. Similarly, we have several Noda Centers all over India. So we are providing virtual lab workshops and training program and all of the necessary support for utilizing this platform. Okay. So these are the Noda Centers under Amrita Vishwa Vidyapita. So we have currently 170 plus Noda Centers. Similarly, all the institute have a lot of Noda Centers all over India. So this is the cumulative growth of Noda Centers. So that representing the importance of this virtual lab project for the benefit of students in their academy. Okay. So these are the training registration from the training program. So we have started the project around 2010. So after that, you can see the cumulative increment in this number user registration, that's representing the importance and interest from the participant for using this platform. So usually we are providing the on-site training. So usually it will be 1 day or 2 day program. So due to this COVID situation, currently we are providing this online support. But there is a drawback, as I mentioned. I can demonstrate the experiments, but only if you are practicing after this, that will be more effective. Only if you are practicing. So this is a little bit about the usage of this virtual lab. So as you can see, the cumulative, the exponential growth of this usage. So currently, Amrita Virtual Lab, we have 6 lakh students are using this platform as part of the curriculum. So that indicate the importance of this project, part of their curriculum. Okay. So for this virtual lab project, we have conducted several research studies. For that, we have 1 patent, 21 journal articles, 10 book chapters, 1 conference papers, and 11 conference posters we have. So all these details are available in Amrita Virtual Lab website. I will introduce some of them. So if you are interested, you can go and explore how this virtual lab impacting students' learning and how that is varying from our traditional classroom, traditional laboratory and virtual lab laboratory session, how the benefit, how the students can easily memorize the concept using this platform. So several research studies that we have included from this platform. So those who are interested, you can go and explore the research publications. So in a nutshell, it is an on-demand lab. Students can learn at their own space and say integrated learning. So all the contents are available in one page, and there is a self-evaluation quizzes available. So students can test their concept or knowledge behind the experimentation before and after performing the laboratory session. So that will enable them to analyze their knowledge about the experimentation. And animation is a video tutorial that will provide a better insight about the experimentation. And also we have provided freedom to make mistakes. Okay, so in a traditional laboratory, we cannot afford to make mistakes that may damage the apparatus. So in virtual lab, this is all virtual. So you don't need to fear about playing around about the apparatus. So it will not damage any of the apparatus. So they can make mistakes, and from the mistake, they can learn better. Okay. So as a social impact, it's a sharing of lab resources, connecting rural and remote colleges, and it's a paradigm shift in ICT-based learning. And it's a platform for exchange of knowledge, and it's a quality improvement in engineering education. Okay. All right. So with that, we have a small video about the project. After that, we will start the experiment demonstration. So I request all of you to watch this video. After that, we can continue with our demonstration.
Virtual labs, broadening perspectives. Technology is radically transforming the learning landscape of modern education. Learning has traditionally been confined to brick and mortar classrooms. This is now changing, with the learning experience extending far beyond the walls of the classroom to become increasingly mobile and ubiquitous. Educational institutions the world over are now looking for new and innovative ways to deliver education in a digital world connected by the internet, the cloud, and social networks. With this in mind, Amrita University is revolutionizing science and engineering education by pioneering a radical new educational tool, virtual labs. Virtual labs are immersive, media-rich, online learning environments that allow users to perform physical laboratory experiments in a computer-simulated environment, anytime, anywhere. This innovative new educational technique is enabling scientific experimentation beyond the boundaries of traditional laboratories. Project background. The Virtual Labs project is funded by the National Mission on Education through ICT by the Ministry of Human Resource Development, Government of India, and is being developed in partnership with IITs and other prominent universities across India. Amrita University calls this project Value Virtual Labs, which stands for Virtual Amrita Laboratories Universalizing Education. This is an initiative dedicated to developing virtual labs in various science and engineering disciplines. Value Virtual Labs provide free and universal access to simulated, animated, and remote experiments to students. Under the National Mission on Education, over 150 laboratories are being built in various disciplines of engineering and sciences. Types of virtual labs. These digital learning tools are enabling students to practice and learn the theory and concepts behind the experiments in new and collaborative ways. Virtual simulations. Here, interactive equipment that can be operated in a virtual laboratory environment is provided. Animations or interactive animation, where students can view experimental procedures in detail. Remote trigger experiment. Here, Amrita engineered cutting-edge technology is used to help students to remotely trigger actual physical laboratory equipment and collect real-time data through the internet from anywhere in the world. Value Virtual Labs uses the most up-to-date subject content and web-based technologies to add a level of interactivity to college-level science courses. Based on the national model syllabi, teachers can easily integrate virtual labs into their classrooms. Through the use of detailed animations, mathematically accurate simulations, and a web browser, students are provided with near hands-on experiences on a large array of physics, chemistry, and biotechnology experiments, with virtual laboratories being developed for mechanical engineering and computer sciences. Specific features of virtual labs. In addition to simulated experiments, these virtual learning environments have a number of features, which include illustrated theory notes, animations, modeling, interactive quizzes, as also workbooks and video lectures that can be viewed as many times as necessary. Benefits for education and society. The vision of this project is to provide free and easy access to high-quality educational resources to higher education students across India, regardless of whether they are based in geographically remote rural areas or economically challenged backgrounds. The free and open access feature of virtual labs allows sharing of scarce and costly scientific equipment with institutions that are less fortunate. This provides the opportunity for students to conduct experiments that they would not otherwise have access to. Virtual labs technology helps bridge the gap between institutions that are able to maintain physical laboratory space and equipment and those economically challenged educational institutions that are not. Impact on institutions, nodal centers. Several nodal centers have been inaugurated and the creation of an additional 32 nodal centers is in progress. Each nodal center inauguration actively engages both students and faculty in demonstrations and hands-on learning of virtual labs. With the nationwide launch of virtual labs by the Government of India, students now have anytime, anywhere access to an encyclopedia of science and engineering knowledge presented in a way that is engaging, immersive, and enjoyable. The result will be a new generation of students that will have equal access to high-quality educational resources. These experiments and labs will be hosted for open access through the main project website at vLAb.co.in and at the university website at amrita.vlab.co.in. With the help of nodal centers and the enthusiasm of the students, Value Virtual Labs are well positioned to help students explore and learn scientific concepts through the exciting and innovative world of virtual laboratories. So, try virtual labs today.
All right. So I hope all of you get the idea about what is virtual lab and what are the advantages of using this virtual lab. So we will go to the demonstration of virtual lab. So if you find any problem or any voice, audio or anything is not clear, please let me know so I can repeat the demonstration again. Okay. All right. So for accessing this virtual lab, we can go to Google and search it Amrita Virtual Lab. Okay, so I'm just entering the Google Amrita Virtual Lab and hit enter. Okay, so you will get the first link vlab.amrita.edu. So you can click on the link. Okay. So this is the home page of Amrita Virtual Lab. So at the top you can see several menus are available. So if you want to know more about the project, you can go to the project menu. Similarly, there is a workshops and nodal center details are available. Similarly, there is a publication, news and events are available. So in this publication, you can click on to see what are the latest journal articles and book chapters, conference papers, etc. So you can see what are the papers that we have published as part of this project. So those who want to explore or learn more about the impact of this virtual lab, you can go to this publication tab. Okay. And at the top, the right, you can see the login button is available. So you have to log in order to access some of the labs from this platform. Okay, so I will provide a default login for accessing this virtual lab. Okay. Yeah, so before starting the session, I would like to know how many of you are using laptop or mobile. So could you please type on the chat box? If you are using mobile, please type in mobile in the chat box. So if you are using laptop, you can type laptop or desktop. So I just want to give the idea about how you are seeing this presentation. So please type on the chat box if you are using mobile, tablet or anything. Yeah. All right. Yeah, thank you all. So I can see majority of you are using mobile platform and some of you are using laptop and tablet. Yeah. So thank you everyone. Okay, so because some of the experiments we have created as a platform independent, so you can use those experiments either in mobile or any of the platform. But some experiment you have to use a desktop or laptop for accessing it. So I will introduce both the methodologies for accessing the experimentation. So from this homepage, you can scroll down to see what are the disciplines are available. So you can see biotechnology and biomedical engineering, chemical science, physical science, computer science, etc. So I will start with physical science lab. So I'll click on the physical science.
Shani, just a update. Sorry to disturb you.
So yeah, please continue, sir.
Everyone has their login ID credential for virtual lab. We received it and we circulate among the student. And second thing, our state government is providing tablet to the PG student and mobile to the UG student. So each and every student is equipped with the digital device. So these also you can start the experiment through your login. So we can know about how we can conduct the experiment through the login. Okay.
Very good, very good. Yeah, thank you for the update, sir. So if you have received the login IDs, you can use the login ID for accessing this virtual lab. So if you do not have login ID, you can contact us by a nodal coordinator. So we can provide new login IDs for accessing it. Okay. So I will start with physical science. Under this physical science, you can see the electricity and magnetism virtual lab at the top. So you can scroll down to see what are the labs available heat and, under this physical science. So you can see heat and thermodynamics, harmonic motion and waves, modern physics, laser optics, mechanics virtual lab, etc. Okay. So I will start with the electricity and magnetism virtual lab. So I'll click on the link. Okay. So in this electricity and magnetism virtual lab, there are several experiments are available. So as you can see, tangent galvanometer, magnetic field around the axis of a circular coil carrying current, deflection magnetometer, Van de Graaff generator. Okay. So you can see some of the experiments that are available in a traditional laboratory, but some of them are you are learning it as a theory. For example, Van de Graaff generators and Anderson bridge Q some of them you are learning it as a theory, but using this platform we can perform the laboratory experimentation. Okay. So I'll start with magnetic field along the axis of a circular coil carrying current experiment. So I'll click on the experiment. Okay. So also I'm sharing the link in the chat box. So if those who are interested, you can simultaneously explore these experiments with my presentation. All right. So as I mentioned, when you are going through any of the experiment, at the top you can see the experiment name, and there are several tabs are arranged. Start from theory. So in the theory, you can see the aim. So very clearly mentioned what is the aim of this particular experimentation, and also there is a video tutorial available. So as you all aware, today none of the browsers are supporting this Flash plugin. So you may not be able to directly open some of the labs or video tutorial. So we can right click on it and open it in a new tab. So if you are using tablet or mobile, you can tap and hold it. So we'll get the menu like this. So you can open it in a new tab for accessing this video or any other Flash related content.
She carried me.
So I'll just go to the theory part. So not explaining details. So you can see what are the details available under the theory tab. So just like about traditional laboratory manual, you can see the apparatus and theory behind the experimentation. So all the derivations, equations, everything is provided under this theory tab. Okay. So I just want to play a few portion of the video so you can see how we have prepared this video tutorial.
Magnetic field along the axis of circular coil carrying current. Aim: to study the variation of magnetic field intensity with the distance along the axis of a circular coil carrying current, and to verify the value of horizontal component of Earth's magnetic field B0. Apparatus: circular coil, compass box, a meter, rheostat, commutator, cell, key, connection wires. Theory: a current-carrying wire generates a magnetic field. According to Biot-Savart's law, the magnetic field dB at a point due to an element of a conductor carrying current is directly proportional to the strength of the current I, directly proportional to the length of the element dl, directly proportional to the sine of the angle theta between the element and the line joining the element to the point, and inversely proportional to the square of the distance r between the element and the point. That is, dB is equal
to the basic theory of the experimentation, and with equation definition, everything is explained in this video tutorial. And
as follows:
describing what are the apparatus and how to do the preliminary adjustment So I'm not playing all this video. So when you are performing it, you can explore and you can see multiple times to get the complete idea about the experimentation. Okay. So in this video tutorial, it will describe every step, how to make the connection and how to take the reading from the apparatus. So all the details are available. So it will reduce the instructor's job. So students, then when they are watching this type of video multiple times, they will get a better understanding about the connection diagram or experimental procedure. So that will enable them to easily perform the real laboratory experimentation. Okay. So it will also mention what are the applications of this particular.
That is characterized by having magnetic surfaces created entirely from external magnets. Traditionally used for fusion research, stellarators possess unique properties that make them attractive as charged particle traps. The principle.
Yeah. So rather than just reading or understand the theoretical or experimental concept, it will provide a application level information regarding each of the experimentation. So that will also one of the information tool for the students. So if you go to the procedure tab, you can see the procedure for performing the real lab. So students can utilize this procedure for performing the real laboratory experimentation. So we have provided step-by-step instruction how to perform the experiments in traditional laboratory. And you can see the tabular column, equations, etc. And there is a procedure for doing the simulator we have provided. So this is the procedure the students have to use to perform the simulator or online virtual lab. Okay. So as you can see, there are step-by-step instruction. So it's very easy to follow this instruction to perform the virtual laboratory. Okay. So if you still find any difficulty for follow up any of the procedure, there is a feedback tab is available. So you can submit all the details into this feedback. Okay. So if you go to the self-evaluation, so there are several questions are available to test the basic knowledge about the particular concept or theory. So you can simply select the answers for each of the questions. Okay. I'm just choosing some of the answers and some of the wrong answers also. And at the right, you can scroll down to the bottom. There is a submit button is available. So you can submit it. So you can see what are the correct answers and what are the wrong answers. So students can verify their answers with either refer to the theory procedure or reference tab. They can find out the answer for each of these questions. So before coming to the simulation tab, I will just complete what are the other tabs contained. So assignment, we have provided 5 to 10 questionnaire for performing the simulation. So these are the questions students can explore or they can perform more laboratory experimentation. So this also teachers can also utilize this assignment question to provide assignments to the student as a take-home assignments. Okay. So in this reference tab, you can see the bibliography link as well as the bibliography links are provided. So if those who want to know more about the experimentation, they can go to the reference tab to get the more details about the particular experimentation. And the final tab, which is feedback. Okay, so we request all the students and faculty members to fill up the feedback after completing each of the experimentation, because we are submitting this feedback report as one of the criteria for usage from the particular for each of the institute. Okay. Also, we are modifying other tabs, simulations, etc., based on the feedback. So it is a request to all the students and faculty members to submit the feedback immediately completing any of the experimentation. So you can choose the type of experiment as simulation or a measurements lab. So there are simple questions are available. How do you rate the online performance? And did you face any problem? So you can mention all the details in this feedback, and you can scroll down to the bottom. So there is a captcha you need to enter over here and submit the feedback. Okay. So once it is submitted, our technical team will evaluate it, and if it is necessary, we will modify procedure, theory, or any other tab based on the feedback. So several times we have modified the procedures based on the feedback. So we are thinking like this is not a perfect platform for learning, but with the help of this Noda centers and students, we can enable this as a perfect platform for complete the learning. Okay. So come back to our simulator. This is the virtual lab simulator. So if you go to the platform, this simulator tab, you can see the apparatus are just like our traditional laboratory. You can see all the apparatus for performing this particular laboratory experimentation. Okay. So at the right top, there is a box icon over here. So you can maximize the view using this box icon. So I'm just click on the box icon. Okay. So when you are maximizing this view in your tablet or desktop, you can see the left hand side, all the apparatus are arranged. And right hand side, you can see all the controls are available associated with this particular experimentation. Okay. So if you are using mobile or tablet, there is a 3-option menu over here in the left top. So you can click over here to access all the control panel. Okay. So as I'm using desktop, I'm maximizing view, and I can perform the experiment from this maximized view. Okay. Yeah. So in this particular experiment, magnetic field along the axis of a circular coil carrying current. So this is the circular coil. Okay. So there is a compass box in the middle of the circular coil. And the left hand side, you can see there are battery, ammeters, etc. So there is a preliminary adjustment which is very crucial for most of the laboratory experiment. So you have to do the preliminary adjustment, then only you can perform the experimentation in this virtual lab also. So for that, in the control panel, only one button is active, which is called initial adjustment. So you have to click on the initial adjustment to start doing the experimentation. Okay. So for this particular experiment, you need to align the compass box 90-90 line parallel with the circular coil. Okay. So this is the 90-90 line. The right hand side, there is a compass box slider is available. This is called slider. So you can click on the slider and slowly drag it. So we can see I'm rotating the compass box slowly. So if you are using desktop or tablet, you can click on the slider, and using your left and right arrow key in your keyboard, you can rotate it like this. So now I'm not using my mouse pointer. I'm using my right arrow key from my keyboard. So I'm just simply click on it. So as you can see, again, step by step, you can change the angle of rotation of the compass box. Okay. So once it is aligned 90-90 parallel to the compass circular coil, the rotate apparatus slider will be active. Now we have to rotate the whole apparatus to align the needle 0-0 line in this compass box. Okay. So I'm just click on the rotate apparatus, and using my arrow key, I'm slowly rotating the whole apparatus to align the needle in the 0-0 line. So once it is aligned, you can click on the show normal. So as you can see, both needles will not coincide perfectly, because in our traditional laboratory, there is a parallax error will be there with respect to the direction of observation. So we have implemented that type of error also in this type of experimentation. So students will get the approximate reading when they are taking the reading from this platform. Okay. So once it's approximately coincide with the 0-0 line, you can click on the show normal button. Okay. So after that, we can make the circuit diagram. So the left top, you can see the circuit diagram over here. So there is a battery over here. This is the battery. Near to the battery, there is an ammeter. So this is the commutator, and the bottom view, you can see the rheostat, and the left hand side, there is a key. So K representing the key. So all the apparatus are arranged such a manner students can easily understand from this circuit diagram. And right hand side, you can see the circular coil. So to make the circuit diagram, you can click one of the terminal and drag it and attach to the other terminal. Okay, so it will attach like this. Similarly, I'm connecting the negative terminal of the battery. Click and drag it and attach with the key like this. Okay, and from the key, bottom terminal of the rheostat and upper terminal of the rheostat to the commutator, and again from the commutator to the negative terminal of the ammeter. Okay. Now the left hand side circuit is complete. Now we have to connect with our circular coil in the right hand side. So for that, I'm taking one connection from the commutator and drag it towards the circular coil. Similarly, I'm taking the second wire and connection, making complete. Okay. So once the connection diagram is complete, there is an insert key button will be active. Otherwise, it will be inactive. So if you're not able to click on the insert button, you have to check whether your connection is complete or not. Okay. So my connection is complete. So I'm just click on the insert button. So we are inserting the key into the commutator as well as the key over here. So immediately you can see the current is flowing through the circuit, and you can measure the ammeter reading. Okay. So in the right hand side, there are several parameters that you can change: number of turns of the coil, radius of the coil, compass position, rheostat adjustment. Okay. So if you are adjusting the rheostat, so you are controlling the current flowing through the circular coil. So when you are adjusting it, you can see the ammeter reading will change. That represent that current flowing through the circular coil that we can vary using this rheostat. Okay. So for taking the reading from this compass box, there is a zoom compass box button is available. Okay. So you can click on the zoom compass box. So students can take the reading directly from this zoom view of the compass box. Okay. So they can also verify what will be the changing any of the parameters from this control panel. So if you are changing the radius of the coil, you can observe what is the change of deflection in this particular compass box. Okay, so in a traditional laboratory, the radius of the coil is always fixed. Students are not able to change it. But using this platform, they can observe what will be the change of radius of the coil in this deflection angle. Okay. Similarly, if you are changing the current from the circuit, you can observe the deflection from this zoomed compass box. Also, the number of turns of the coil. So all the parameters, they can vary and take the reading from this platform. Okay. So how to perform this experiment? You have to change the compass position towards or away from the center of circular coil. So, okay, so I can move the compass position using the slider over here. Okay. So from each position, students have to take 8 deflection angle. Okay, so they have to take the reading from this platform, and they have to manually note the reading and calculate the particular derivations or equation provided in the theory tag, and they have to verify whether their answer is correct or wrong using the show result button provided in the control panel. So you can see the checkbox over here, show result. So while check on this checkbox, you can see the final result of the experimentation. So students can verify whether their answer is correct or wrong with respect to their reading. Okay. So we have provided one more additional feature. This is called a workbook. Okay, so majority of the complicated experiment, we have provided this type of workbook. So students can directly enter the reading over here. So for example, in this particular experimentation, our number of turns of the coil, which is 20. So I'm entering the value over here, 20. And current from the circuit, which is 0.238 ampere. Okay. So I'm entering the reading 0.238. And radius of the coil, you can measure from here, 6.1 centimeter. Okay. 6.1 centimeter. Then distance of the circular coil, which is 4 centimeter. Now we have to take the theta deflection from the compass box. Okay. So for that, you can use the zoom button. So here you can see approximately 40 reading. So you can enter the value over here, 40, theta to 40. Okay. So now we have to reverse the current flow through the circuit. Okay. So using this commutator, we can change the flow of the current using the reverse key over here. So there is a reverse current button over here. So you can click on here to reverse the current. So again, click on the zoom compass box. So now we get the different angle. So we get the 40 angle in the reverse direction. So we have to enter the value over here. Okay. So as you can see, this is the left hand side. So I'll just show that. Currently, we have placed the compass box into the 4 centimeter. So we have to place it the same distance towards us, 4 centimeter. Okay. Again, you have to take the reading from the compass box. Okay. So it will get almost 40 for all the angle. So total we'll get an 8 reading from one direction, and yeah, for both direction we'll get the 8 reading. So after entering all the readings over here, it will automatically calculate what the tan theta value, Vx and V0. All the readings it will automatically calculate. So it will be a very easy tool for the students to immediately complete all the experimentation. Okay. So if you want to increase the row in this workbook, there is a plus icon over here. So you can click on the plus icon to increase the row. Similarly, you can use the minus icon to delete the row. Okay. And also you can print it as a PDF file or save the file to the desktop, and you can submit for grading purpose. Okay. So this is how you can perform the magnetic field around the circular coil. So I'll just repeat it again. Some of the experiment, there is an initial adjustment you have to do, otherwise you cannot do the experimentation. So you can look for the initial adjustment. After that, you can follow the procedures provided in the procedure tab. Okay. So just show the procedure. So I have just completed the initial adjustment. Then you can see rotate the compass box, rotate the apparatus. So very step-by-step instruction followed here. So if you stuck somewhere in the middle of the experiment, always refer to the procedure tab to complete the experimentation. Okay. So this is how you can perform this electric circuit experimentation, electricity and magnetism virtual lab. Okay. So another one is, yeah, I will do one of the experiment from electric circuit virtual lab.
Hello,
Sunny.
Sunny
Yes,
sir.
yes, sir. Yes.
Sorry to interrupt you.
Yes,
Can we
please, sir.
start some biochemistry experiment also?
Yeah, sure.
Actually, most of the students are from a biology background.
All
So
right,
it would be better for that.
All right.
Yes.
Okay.
Thank you.
So I'll just go to the home page and go to the biotechnology and biomedical engineering. So I'll just click on the experiment, biomedical engineering. Okay. So as you can see, there are several labs are available: biosignal processing, bioinformatics, neurophysiology, biochemistry virtual lab. Okay. So in this biochemistry virtual lab, there are several experiments are available: qualitative analysis of carbohydrate, isoelectric precipitation of protein, casein from the milk. So I'm just click on the experiment: isoelectric precipitation of protein, casein from milk. Okay. I'm sharing the link in the chat box also. Okay. So there is a video tutorial is also available. So you can, without reading the most theory, you can directly go to the video tutorial as I mentioned. So as we are already go to the other tab, you can directly go to the simulation. So you can see there is an animation view is also available for this particular experimentation. So if you find any error like this, fail to detect flash player, click here to enable flash player. So none of the browsers will support this flash content. So if you are using mobile platform, there is an browser called Puffin. So and we'll provide the link over here, not the link. You can go from the Google or Android or Apple Store. You can download it. Okay. So I have provided the name in the chat box, Puffin browser. Using this browser, you can access this flash enabled content. So if you are using desktop or tablet, we have in the procedure tab, we have provided how to access this flash content. Okay. So you can see flash EOL, EOL representing the end of life. So I'm just opening in a new tab. Okay. So I'm just opened from the procedure tab. I have opened the flash EOL link. So you can see Adobe Flash end of life. So since Adobe no longer support flash player, so we have an alternate method for accessing this flash content. Okay. So there you need to download one flash debugger for Windows, Mac or Linux. So if you are using Windows system, you can click on the Windows link over here. So if you are using Macintosh, you can click on the Macintosh. Or if you are using any of the Linux distribution, you can click on the Linux link over here. So I'm using Windows system. So I'll just click on the Windows link over here. So it will directly download the setup for accessing the flash content. Okay. So I'm just downloading here. Okay. So I'm just downloading the executable file into my download folder. So I have already downloaded. I'm just
downloaded my laptop, but I'm unable to open it.
Yeah, I will show that also. Okay. So after downloading it, this is the flash player. So you don't need to install this flash player. You can simply double click on it. So if you are using Windows 11 or 8, there will be a pop-up will come like this.
Can you repeat the process same?
Yes, yes.
Because I am paste the link vLAb.amrita.edu repo biotech.
Yeah, I'll share this link also in the chat box.
Yeah.
I have shared one link in the chat box. So you can click on the link for accessing this particular web page. So from that, you can click on the Windows link over here. So those who are using laptop or desktop, you can do the same. So only one time you have to download this flash player. So after that, you don't need to download any of the setup for accessing this virtual lab. So you can click on the Windows link. So it will show a pop-up for downloading the file. So you can download anywhere in the desktop. Okay, after saving the file, you can open it. So I have downloaded into my download folder. So this is the file. So I'm just double click on it. Okay. So if you're using Windows 11 or 8, there will be a pop-up like this. You can click install anyway. So it is not required to any complicated step. So just install anyway. It will, yes. Yes, sir.
When I download the flash player for Windows,
Okay.
there is a flash player 32 exe file. When
Yes.
I try to open it, Just Adobe Flash Player 32 open. There's
Okay.
nothing. So what to do?
Yeah, did you get this window, sir?
Yes, I get this window.
All right, just follow my procedure. So it is not completed yet.
Okay.
Yeah. So once open the file, as sir mentioned, you will get a window like this, Adobe Flash Player 32. So this is the window I have opened. Okay. So for accessing, you need to follow this step. So step 1, we have opened the Flash debugger, Flash Player. Step 2, you need to copy the Flash content link from the procedure tab. Okay. So I'll go back to my procedure tab. Okay. So in the procedure tab, you can see the link over here, animation link. So I'm just copy the link from here. Right click and copy the link. After that, go back to my Flash player. Okay, so this is the Flash player. And from here, you can go to the file and click open button over here, open link. Okay, so here you have to paste the link. Okay. So I'm just pasting the link. After that, click OK button. Okay, so you can just repeat the same procedure and let me know if you are not able to access this particular window.
Okay.
So I request all those who are using the laptop, you can follow the same procedure. Download the Flash plugin.
Yeah. Now it's okay.
Right. All right. Okay. So just for those who are not accessed, I just repeat it again. You can, if you find any Flash related error or anything in the Flash or animation tab, you can refer to the procedure tab. So in the procedure tab, you have to download this Flash player. After that, you need to copy the link from the procedure tab. And from the Flash player, you can go to the file, open, and there you can paste the link and click OK button. So it will load the Flash content in your desktop. Okay. All right. So just this is the animation. As I mentioned, this is the animation link. So there is a simulator that you can access directly from your mobile or desktop. Okay. So in this animation, it will provide what are the step-by-step procedure the students usually have to follow in the traditional laboratory. So there is a start button over here. On the right top, there is a several controls over here: pause, forward, play, etc. So I just click on the start button. Okay. So now you can see what are the apparatus that students have to access in your traditional laboratory. So you can place the mouse over here. So it will show the name of each of the apparatus. So okay. So you need a milk over here. This is the pH meter. And this is the electrode, and there is a burette over here. Okay, so this is the magnetic stirrer and the weighing machine, measuring jar, centrifuge tube. Okay, so these are the minimum apparatus equipment for this particular experimentation. So there is a continue button over here, so you can click continue to watch this animation. Okay, so in this animation there is no audio is available. You can read the subtitle over here. So if you find difficult to read it, there is a pause button over here. You can pause it and read the subtitle and play the animation. Okay. So it very clearly mentioned what are the step-by-step instruction, how to hold each of the apparatus. Okay, so now we are taking 25 ml of milk into the centrifuge tube. Okay, close the tube tightly and keep it in a rack. After that, we have to fill the milk into the another 3 centrifuge tube also. Okay. So it is clearly mentioned how to place the centrifuge tube into the chamber. So how to make the balance while rotation.
This is an animation, simple animation.
This is a simple animation to provide the basic steps for performing the real laboratory.
Okay. After the we can conduct on vLAb.
Yes, yes. So some vLAb experimentation, we have not provided all this procedure. So some of the initial adjustments or setup, students have to watch this animation to understand it. So other part of the experiment, you can perform it as a simulator. Okay. So after watching this animation, you can directly go to the simulation tab. So this is a simulation. So I'm just maximize the view using the right top. There is a box over here. Okay. So in this particular experiment, there is a instruction provided in the control panel.
For simulation, it required login. So we have to log in.
Yeah, you have to log in. So you have to log in for accessing most of the simulation from this platform. So after logging it, you will get a window like this. Okay, so you can maximize this. So in this particular experiment, there is an instruction over here. So there are 5 steps the students have to follow. First, you need to click and drag the centrifuge milk to pour into the beaker connected with pH meter. Okay. So this is the beaker over here. So this is the centrifuge milk over here, and we have a distilled water, and this is the electrode connected with this beaker, and we have a burette over here, and we have filled hydrochloric acid into this burette. Okay. So we need to pour this milk into this beaker. For that, you can click and drag the milk like this and release the mouse button near to the beaker. Okay. So you need to measure either 100 or 200 ml. So when it is 200 ml, you can click on the milk again to put it back. Otherwise, it will pour all the milk into this beaker. Okay. So purpose is yeah. Yes, sir.
Once here we have poured the milk as 100 ml and I want to increase the amount to 200 ml. So I cannot do it again.
Yeah. So if you want to make 200 ml, you need to click the reset button and
Reset after reset.
Yes. So I have taken almost 200 ml of milk. So now click and drag the distilled water and pour into the same beaker to make it equal volume. So that is very important step. You have to pour the distilled water. So same volume. That means you need to pour the 200 ml to make it approximately 400 ml. So just click and drag the distilled water and release the mouse button. Okay, so we be ready to click on this distilled water when it reaches 400 ml. Okay. So as you know, we have poured into 400 ml. So if you make any mistake, the message, there is a message bar over here. So it will provide a mistake or an error message if you are done it is incorrectly. If you have done it any mistake, if you made, it will pop up on this message bar. Okay. So after pouring the milk and distilled water, we need to click the stopper of the 2-art hydrochloric acid into this beaker. So as you can see, this is the burette. There is a stopper over here. So you can click on the stopper. Okay. So we are drop by drop pouring the hydrochloric acid into this beaker. So simultaneously, you can measure the pH reading using the pH meter. Okay. So when it reaches 4.6, our milk will get precipitated. So that's what we need to observe. Okay. So as you know, we have to carefully stop the dropper when it reaches 4.6 pH reading. Okay. So if you are repeating it again, the error message will pop up. So students can repeat it to understand where you have to stop this burette knob. Okay. So this is how we can perform this particular experimentation. So as you see, with this very simple step, but once you are watching this animation and perform this particular virtual lab simulation, you can easily control your real apparatus. So you can easily perform your real traditional laboratory experimentation. Okay. Yeah. So next we will go to one more experiment from biotechnology. Okay. So from immunology virtual lab, blood grouping experiment. So it is good to know how the traditional laboratories or hospitals are doing this blood grouping. So all these details are provided in this particular experimentation, blood grouping experiment. Okay. So the theory tab consists how this blood grouping are differ, what are the factors identifying for each of the blood group, etc. So I directly go to the animation. Okay. So as you can see, it failed to detect the flash layer. So I'm referring the procedure tab. So in the procedure tab, as I have already downloaded this Flash debugger, I can simply copy the link from this procedure tab. Okay. And go back to our Flash debugger and go to the file, open, then paste the link over here. Okay. And click OK button. So it will load the animation into this Flash debugger. Okay. So this is interactive animation. So that's why I prefer this particular experimentation. So let's see how to perform this with interactive animation. So you can click on the start button. So certain portion of this animation, just like a watching video. So you can simply watch it, how to perform this particular experimentation. So you need to take out the alcohol pad from this packet. So as you can see, all the waste, everything you have to carefully deposit into a chamber or waste basket. So every step is very clearly mentioned in this particular animation. So you need to put the alcohol pad in the tip of the finger. After that, we can take the lancet to collect the blood from the fingertip. Okay. So you can prick the fingertip and prick with the lancet. So as you can see, after that we have to put it into a biohazardous chamber. Then we need to collect 3 drops of blood into this glass bead. After that, we have to place the glass bead into the table over here in your laboratory. So it's a very important. You have to cover the fingertip with the cotton ball. Okay. Yeah. So after that, you can see I can control this hand using my mouse pointer. So this is called interactive animation. So now we have to perform this procedure as mentioned in the subtitle over here. So we need to place anti A in the first spot of and by anti B into the second, etc. So you can read the procedure and perform it. So I'm using anti A, click and drag it, and release the mouse button on top of the first drop of blood. Okay, so we are pouring 1 drop of anti A into the blood. Similarly, we are using anti B, second drop of blood. So I'm releasing the mouse button. Similarly, we have to use monoclonal D into the third drop of blood. Okay. So after that, we need to mix the blood sample with this anti A, B, and D, etc. using this toothpick. So you can click and drag the toothpick and carefully mix the sample. Okay. So if you are using the same toothpick for mixing another sample, you can see use another toothpick to mix the drop blood. Okay. So that is a very important step. So you should not use the same toothpick for mixing different blood sample. So every time you have to use the fresh toothpick for mixing it. Okay. So after that, release the mouse button. It will automatically deposit the biohazardous chamber. Similarly, I am mixing the third drop of blood and releasing the mouse button. Okay. So now you can see continue button will appear. So you can click on the continue button. Okay. So this is our sample look like. So as you can see, first 2 drop of coagulated and third one is not coagulated. So this is one you need to observe. And there is a chart over here at the right hand side. So students can easily map with this chart and they can identify the blood group. So for example, in this particular sample, first 1, 2 are coagulated and third one is not coagulated. So it is AB negative. So you can click on here. So it will show correct answer based on our selection. So if it is wrong, you can repeat the experiment several times for getting the complete correct answer. Okay. So this is how you can perform this particular experimentation. Blood grouping experimentation. Similarly, I request all of you to go and explore from based on your background. You can explore from other experiments from biotechnology and biomedical engineering. So now I will go to chemical science, some of the labs from chemical science also. So just click on the chemical science. So is there any student from chemical science or chemistry? Please type in the chat box yes if there is any student. Students or faculty, please type in the chat box yes or yes if you are from chemistry.
Shanish, we can start with estimation of glucose.
Okay.
In organic chemistry virtual lab, the estimation of glucose in the third row.
Right. Okay. So in organic chemistry virtual lab, you can find estimation of glucose. So yeah, I'm just opening the link over here. So in this experiments also, you can see the animation and simulator, etc. So you need to watch the animation first before performing the simulator. So as I mentioned, there is a link over here. You can use the link for watching this animation because the preliminary setup, all these things we have provided as animation. So only the experiment part we have converted into as a simulator. Okay. So in this simulator, you can see we have a conical flask burette over here. Okay. So you can see the titrant and everything is filled up already in this burette. Okay. So the preliminary, all the setup will be available in the animation video also. So we request you to all the students to watch the animation first, then you can perform the simulation. Okay. So in this particular experiment, you can see the titrant over here: watermelon, tender coconut, soft drink, So you can choose based on your assignment, or this faculty members can use it for providing assignments to the students, so they can find it very interesting for performing this from this platform. Okay. So after selecting the titrant, so I'm choosing tender coconut. We can choose the speed of drop. Okay. So from this burette, we can choose the speed. So in our traditional laboratory, we can loosen this knob over here, but in virtual lab, you have to use the slider for increase or decreasing the titration speed. So you can see the titrant is filling solution. It's already fixed over here, and you can change the normality of the solution. Okay, and you can choose the volume. So in this conical plus, you can, when you are changing the volume, you can see the volume of the solution is changing, etc. All right. So after that, you can, there is a start button over here, and there's a methyl blue over here. So that is an important step. You can use the methyl blue after the first step of the experimentation. So I'm just click on the start button to start the titration. Okay. So as you can see, we are just started the titration. So we need to look for the color change occurred in this conical plus. So usually what we are doing is we need to increase the speed of the titration. Okay. So when it is reaches color change endpoint, you can stop the titration using the stop button over here. So I'm looking for the endpoint in this particular experimentation. Okay, so as you can see, there is a pop-up will come up, add methyl blue into this particular experimentation. So we need to see this is the endpoint color change that students have to observe in the traditional laboratory. So when they reach the endpoint, they have to stop the titration and add methyl blue for continue the titration. Okay, so I'm adding the methyl blue. Okay, then again we need to start the titration. Okay, so we need to observe for the color change occur. So as you can see, now it is transparent, colorless solution. So that is what students have to observe as an endpoint. So there are two endpoints are here in this particular experimentation. So when students performing it in multiple times, they can easily understand what are the color they need to observe in the traditional laboratory, and how the volume of this titrant will change with respect to the normality and volume of the titrate, etc. That all details they can observe from this platform. Okay. And as I mentioned, there are several options are here. So as a slider, faculty members can prepare an assignment for the students. So students can perform it and they can submit the assignment, etc. All right. So I hope that understood. So I will show one more experiment from this chemical science, which is spectrophotometry from physical chemistry virtual lab. So you can observe how we can perform such kind of experiments. Okay, so I'll directly go to the simulator. All right. So this is our spectrophotometry experimentation. So this is called a spectrophotometer. So we need to identify the unknown concentration using the non-concentration solution. Okay, that is the aim of the experiment. Okay. So there are several solutions are available. You can see cobalt, hexacobalt, fluorescent, crystal violet, etc. So I'm using crystal violet for this particular experimentation. Okay. So at the top, you can see there are two solutions over here. One is a non-concentration, another one is unknown concentration. And there is a blank cuvette also provided. So because this is spectrophotometry is somehow costly equipment, some of the institutes are not using these experiments are part of their laboratory courses. But using this platform, you can explore how to perform this experimentation. Okay. So after selecting the solution, you can change the concentration of the solution. So I'm choosing it as 0.03 m as a concentration of the particular solution. So now first we need to calibrate this spectrophotometer. So for that, you can open the lid of the spectrophotometer, just click over here, and we need to place the blank cuvette. So all these procedures are provided in the procedure tab. So I'm just follow up the procedure. So if you find any difficulty, always refer to the procedure tab. So after place the blank cuvette into the chamber, you can close the lid over here, and you can see there is an absorption and transmission over here. So we need to calibrate it to get the zero absorption. That means when light is passing through the cuvette, none of the waves are absorbing. So we are calibrated this spectrophotometer. After that, open the lid and take out our blank cuvette. Then we need to place the non-concentration. Okay. So we are just click on it. It will automatically place into the chamber of the spectrophotometer. Then close the lid of the spectrophotometer. Now we need to increase the wavelength passing through this particular solution to identify what is the maximum absorption value. Okay, so I'm click on increasing the wavelength. Okay, so at some particular points, for example, 400 nanometer, you can see the absorption value is 1.276. So if you are increasing the wavelength, the absorption will decrease. And if you are decreasing the wavelength, absorption value again decreases. So this is the maximum absorption value that students have to observe from this particular platform. Okay. So for the calculation part, I will just refer the procedure tab. So you can right click on the procedure and open in a new tab for accessing the procedure and simulator simultaneously. Okay. So I have a two separate tab, one for simulation and another one is procedure. So if you are doing the simulation and click on the procedure, that all setup will be reset. So you have to start from the beginning. So that's why we are preferring to open procedure in the separate tab. So first we need to understand, we need to calculate the molar absorption coefficient, that is it is equal to A by Cl. So I'm using the Excel file for the calculation. All right. So this is typically how students are performing this experimentation. So we need to calculate the molar absorption coefficient. So suppose E considered as molar absorption coefficient. So our parameters are absorption value, which is 1.2769. So I'm entering the value over here. Okay. All right. So the equation is epsilon equal to A by Cl. So I'm substitute our value over here. Epsilon equal to A by Cl. So our concentration we have selected from our slide over here, which is 0.03 m. So I'm entering the value 0.03 as a concentration. And L is the length of the cuvette. In our simulator, we have mentioned the length of the cuvette, which is 1 centimeter. So I'm entering the value over here 1 centimeter. Now we have to substitute value over here.
निधि डाल देगी
Epsilon equal to
कहा करी देख लो
portion divided by concentration into length of the cuvette. Okay. So we got the molar absorption coefficient as 42.5633. Okay. Now we can take out our non-concentration from this spectrophotometer. For that, I'm just opening the lid and click on the solution over here. Now we have to place the unknown concentration into this chamber. So just click on the unknown concentration. So it will automatically place into the spectrometer chamber, spectrophotometer. So after that, close the lid. Okay. So without changing any of the parameters, you can take the reading from this spectrophotometer. So we need to take the absorption value over here. Okay. So I'm using A dash for the new absorption value, which is 0.2426. Okay. So we need to find concentration for the unknown concentration, C dash. So I'm just rearranging the equation, C dash equal to, rearrange this molar absorption equation, which is equal to A divided by E into L. Okay. So I'm just substituting the value over here. C dash equal to absorption value divided by molar absorption coefficient into length of the cuvette. So our unknown concentration is 0.0057. So we can verify whether our answer is correct or wrong. So here we can enter the value over here 0.0057. Okay. So after that, you can click on the submit button. So it will show correct answer. So if you have entered the wrong answer, for example, 0.0056 instead of 7, so it will show a pop-up like wrong answer. So you have to repeat the experiments or repeat the calculation in order to identify the correct answer. So this is how you can perform the spectrophotometer experiment from this platform. So initially you will find some difficulty for performing the experimentation. So you have to refer the procedure tab, then come back to the simulation and do the same procedure into the simulation. So once it is familiar with this platform, you can easily save the time for completing the experimentation as well as perform the real laboratory experimentation. Okay. So this is how you can perform this chemistry related experimentation. And one more experiment from physical science, which is related to the electric circuit. So I'm using electric circuit virtual lab from the physical science So I'm using parallel LCR circuit. So as you can see, Adobe Flash Player is no longer supported. I'm using the procedure tab and copy the link from the procedure tab and go back to our Flash debugger, Flash Player, and go to the file, open, and paste the link over here. Okay, and click OK button. So I'll just repeat it again. If you find any error or anything goes wrong related to the Flash Player, we can refer to the procedure tab and copy the link, start from HTTP to the .sw zip file. So you need to copy the file and open your Flash Player, go to the file, open, and paste the link, then OK button. So you can successfully load the Flash content in your desktop. Okay. So this is the platform for performing the AC circuit simulation. The right hand side, you can see all the equipments or components are available. So you can simply click and drag the component like this. Okay, so I'm taking one inductor, capacitor. Okay, so we need a power source. So you can click and drag the power source. Using one switch over here, click and drag it. Okay, so these are the wires for making the circuit diagram. Okay. So for making the connection, you can click one end of the wire and attach it to the component like this. Okay, so now you can see there is a color change occurred that represents your connection is perfect. So you should not place the wire into the component terminal like this. So it is look like connected. When you are moving the component, wire is still in the same position. So if your connection is perfect, when you are click and drag the component, you can see the wire is also moving along with the component. Okay, so you have to make sure whether your connection is complete or not. Otherwise, you will not get the correct answer. So similarly, I'm just printing the circuit diagram. Okay, so I'm just click and drag to take the number of necessary wires for this particular experimentation. So I'm connecting the left hand side and keep connecting each wires together. So as you can see how easily one can perform this particular electric circuit related experiment from this platform. Okay. So I'm connecting the left hand side with our power source and power source with our key, so mechanical key. Okay. So there are two types of ammeters are available. This is one is non-contact ammeter and another one is contact ammeter. So this is the contact ammeter. So just like our traditional laboratory, they can connect it series with our circuit diagram. Okay. All right. So we have a voltmeter over here. So this is called voltmeter. So now we can change so many parameters associated with this particular experimentation. So on the right hand side, you can see there is a select view, lifelike and schematic. So some of the students and faculty members are like to see the schematic type view. So they can switch to the schematic. So it will represent the schematic of the particular diagram. So I'm using lifelike to get a much more feel of the apparatus. Okay. So now you can change the parameters, each of the component value. So I'm click on the power source. So while click on it, you can see the right hand side. You can change the frequency, entering the frequency as 100 Hertz and RMS voltage as 50 volt. Okay. Similarly, we can enter each of the parameter value, component value. For resistor, you can see the slider over here. You can change the resistance value. So you can note that when I am changing the resistance value, the color code is also changing with that. Okay, so students can easily verify whether their color code is correct or wrong with respect to the particular resistor value. Similarly, I'm changing the inductance and capacitance value. So after that, we can switch on the power source. So there is a white switch over here. So when you are switch on it, you can see the green light indicate our power source is switch on. So now we need to switch on the mechanical switch. So just double click on it to switch on this mechanical switch. So I'm just double click on this mechanical switch. So immediately you can see the current is flowing through the circuit, and you can measure the voltage and current, etc. So using this non-contact ammeter, you can place anywhere in the circuit. So you can measure the particular current flowing through the particular branch of the circuit. Okay. So that is one of the handy tools. So if you reduce the inductance value, you can observe what will be the error that can happen in our traditional laboratory. So I'm just reducing the inductance value. That means we are directly making the short circuit. So that will damage our apparatus like this. Okay. So that type of mistake students can verify using this type of platform. Yeah. So this show value representing the values of each of the components. So they can easily take the reading or verify whether the component values are correct based on the assignments or tasks, etc. So this is how students can perform the AC circuit or any electric circuit related experiment using this platform. Okay. So yeah. So I hope all of you understood how to perform any of the experiment from this virtual lab. So one is the simulation and interactive animation. So remote rigor we are not covered today's session because that are shut down. So I request all of you to go and explore more experiment from the platform based on your respective curricula. And while performing it, as I mentioned, there will be a struggle for familiarize with this platform. So once it is familiar, you can easily hand over any of the experiments. Okay. All right. So that's all from today's sessions. I hope all of you are enjoyed. And thank you very much for patiently listen to the session. So you can share your feedback, how you feel about the workshop. And we are very happy to hear from students and faculty members. So hand over to Neha for the conclusion session. Thank you all.
Wow, sir, such an interesting topic, and it was really amazing for us to learn a lot from this workshop. And I'm really very much thankful to you that you provided us the platform to learn from this kind of workshop, and very optimistic about all of our faculty to get more and more up, from this kind of labs and experiments. And further, I would like to thank you for giving us the opportunity to share the platform with you people, and will be hopeful that you will provide us many more workshops like this in future also. Thank you so much, sir, once again. And further in the sequence, I would like to invite Dr. Neetu Singh, ma'am, for the formal vote of thanks.
Thank you, ma'am. Thank you, Neha, ma'am. Hello, good evening, everyone. It gives me an immense pleasure to deliberate the vote of thanks for this wonderful workshop to all dignitaries assembled here. We are grateful to our principal, ma'am, first of all, for her words. I thank her kindness and continuous support. I would like to express my heartiest thanks to Mr. Sanish, PF, Project Manager, and his team. Here we have Mr. R. Venkatesh from Manager Lesson Tech, and all over the team who are doing such a wonderful workshop to develop a scientific attitude among students. My heartiest thanks to our HOD of Zoology and the nodal officer of this workshop, Dr. D.C. Sharma sir, for his stewardship, support, vision, and commitment. I pay my gratitude to all faculty members for their valuable contribution and efforts in making this workshop worthy. Last but not least, I thank you, dear students, in making this workshop a resounding success. Finally, I leave you with this inspiring quote by Martin Luther King. An individual has not started living until he rises above the confines of his individualistic concerns to the broader concerns of all humanity. Once again, I thank you all for your attention. Thank you very much.
Before final thanks, I have some question from Mr. Sanish.
Yes,
Sanish, I'm going to share my screen, and I have to share my views with you, because no doubt there are a lot good experiment you are defining here, and there are a lot of experiments which are related with the life sciences also, traditional UG students. But what do you think? What is the major problem or reason behind it that they are not much so popular?
Yeah, so as you have mentioned that we are conducting this type of workshop for make awareness about this platform. So still there are a lot of institutes are not aware of this platform. So this is our kind request. You can inform your nearby institute and your other colleagues or friends working nearby any other colleges. They can utilize this platform because Government of India providing so much fund for developing this virtual lab for free of cost for enhancing our students' education as per the curriculum. So yeah, that's why we are also conducting this type of Nodal Center programs and workshop, etc. So thank you for mentioning that, sir.
What my observation? Actually, you mentioned that you are targeting most of the University of India during developing these experiments.
Yes.
Instead of targeting most of the student of India, you are targeting universities of India. Because as I see in your list of the experiment, there's a lot of gap in traditional graduation subject, or you can target 100, 200 universities like central universities, but they are catering a few students only.
Yeah.
You are not targeting the university, state university, which are running the affiliated college, billions of students, or you can say 90% of our students are catered by these universities. Yeah. So first, we have to target these students instead of only some national or renowned universities. Second thing, what I noted in this, that the language is a big problem. So you have to translate your experiment in regional languages. Like Hindi, it is a requirement, big requirement. If the experiments are available in Hindi, they are more popular. So these are, you can take it my suggestion or feedback that you have to target, you have to identify the gap of the syllabus. And second thing, you have to target the developing or translating the experiment in the regional languages.
Right, sir. So we have received so much query related to that for translating into regional language. So hopefully we are on phase of adding new experiments. So along with that, we have also mentioned, also proposed to convert into different languages. So in that case, we required this Nodal Center support also for converting this content into their regional languages. So yeah, we are expecting that type of collaboration with Nodal Centers for future development.
I'm sharing my login with you.
Yes.
I find out in LMS attendance, there's a 93, 34 attendance are there. Yes. If I click on 93, the list of ideas there. Is it not possible that we have to identify name of the student? Because it is very difficult to identify the student name with the ID. We share student name, email ID, and mobile number to you. So there must be a one more row in which the student name must be there. So we can easily identify which student is conducting experiment, which or not conducting experiment. Because there's only username is there. Second thing, there's some logout, exit. What does it mean? Some is mentioned, exit is there, logged out is there. So what is the difference between logout and exit?
Yeah. So I just want to mention this is an add-on feature from our virtual lab, Amrita Virtual Lab platform. It's a scaled-down version of a learning management system. Okay, so in this, we are providing a facility for tracking whether students are access this virtual lab or not. So the faculty members can track whether your students are access or not. So in this particular view, we can username because we are identifying each individual based on the username because that is the unique ID for each username.
Yeah, but we also share the name with we all share the name, email ID, mobile number to you. So you can add another row in this column in this. That name of the student must be there. So it is easy to understand, identify which student is not taking the class because it is very difficult to identify the name of the student by the using just username.
Right, right. So I can request you our development team for adding the new row also.
New row, yeah, please.
Yeah, and this exit and logout that representing those who are proper because after 18 maximum 50 minutes it will automatically log out. So so that means logout. Exit means they are closing the tab without logout properly. So that is the difference.
Okay. Second thing, when I adding any instructor with the use of username, the name reflected in the request from student, not as a faculty.
because students have to request an inserter.
No.
So we can.
When I send a request to student, it's okay.
Okay.
But when I send a request to Neetu Singh, in Neetu Singh login, my name is visible as a student request, not as a faculty request.
Yeah, because
You can show this one.
Yes, sir.
I am reflected as a student. Instead of faculty, I am reflected as a student in the Neetu ID.
Yes.
Right.
Login.
So the purpose of these facilities, only the faculty have this manage group, manage student, all those, that instructor, left hand side, you can see the instructor privilege. So only the faculty members have those privilege. Okay. So the faculty member can create an online group or create a questionnaire online, and you can provide an online assessment using this platform.
Can you explain how?
Yeah.
How
But
manage
that
the
instructor
assignment?
Yeah. Yeah, that part I have not covered because of our time constraint. So there is a separate session. So if we can arrange one more workshop for future, we can explain that also. Because of the time constraint, I have not touched that LMS platform actually.
Next time we will try to do the experiment. We and our student will try to do the experiment on the platform and come with the.
So is there any other LMS system using in your institute, sir?
Right now, we are not using LMS system. We are just using the Apple iPad system. They are providing their own LMS, in which I think this facility is not indicated.
All right. So in that case, you can use this platform for some type of online assessment and scoring. You can use this platform.
Okay.
So yeah, there is an instruction over here, and that there is an instruction help menu is also available. So maybe we can next session can describe in more details.
And we are our nodal center for your vLAb, but our name is not visible on your website.
Yeah, so we will add it based on the usage. So I think our technical team not consider that usage yet. So I will push that also. Maybe next week or start, you can see the list over there.
Okay, thank you.
Thank you.
Okay,
Okay, sir. Thank you, sir, for such a wonderful workshop. And I want to add something else, that there is some leak of, I think, lack of biological experiment, of classical biological experiment.
Hello.
So can you add or do something about it? Classical biological experiments like dissections and slide making, etc.
Yeah. So if it is available any particular lab, as I mentioned, you can send us the list of new experiments for the future development. So we are already started the next phase of development. So we are also requesting accepting any request from nodal centers for creating the further experimentation. So you can provide the list of experiments to us, so we will consider for the further development.
That will be very helpful for our students, especially of biological background.
You have to work on two directions. One is the translation of experiment, and another is new experiment to fill the bridge. Okay.
Yeah.
Right, sir. Yes.
Can we conduct practical exam on this virtual lab?
Definitely. So in our Amrita, we are conducting one practical exam, especially for this virtual lab. So we will provide certain assignments. As I mentioned, there are several parameters. The faculty member will decide 3 parameters for the experimentation. So students will get a half an hour or 1 hour time for complete the assignments. So they have to complete the experiment, and they need to take the screenshot, and they have to submit the screenshot with the result. So we are providing such kind of, we are conducting such kind of online assessment also using this platform.
Thank you.